Here's another example. I've taken the same two shapes that we already proved were congruent, but now I've moved one of them. Let's see if we can still find a sequence of rigid transformations that establishes why these two shapes are congruent. So this time, I'm going to start by trying to align 2 points. Now I can move any two on top of each other, but I'm going to choose to move B onto E prime. I can tell that those two go together. If I want to move one point on top of another, is use a translation along a vector. I need to move B to E prime. Translate by vector, this figure by this vector. So I've translated along vector B, B prime. I have two options now. I've already translated and put one point on top of the other, so I'm either going to use a reflection or a rotation to make my final move. Take a moment. Which do you think would be better? Let's try it first with a reflection. What I notice, and the reason I'm thinking reflection, is that this pointy part is fanning out towards the right on this image, but it's fanning out sort of down and towards the left on the other red one. I don't want to have to keep calling it the other red one, so let's make it green. If you're not exactly sure, start by just flipping this over along one of the segments of the image itself. So I'm going to reflect this image about the line segment A prime, B prime. So that'll fix that side, but flip the other part up. It'll flip up point D and point C prime. So now we have this new image that is orange. And notice now that it fans out in the same direction as the blue one. And that if I were to just rotate around A double prime to F prime, D double prime to G prime, C double prime to H prime, they would line up. The only question is, how far a movement is that? To figure that out, I'm going to take 2 points that correspond and consider the size of the angle formed by their rays through the point they have in common. So we've already lined B up. I'm going to take A double prime to B double prime to F. Whatever that angle measurement is, that's how far I need to rotate to get A double prime to land on F prime, and to have that whole segment land up on the segment from B double prime to F prime. Now in GeoGebra, I can measure this using a measuring tool, but if you didn't have that, you would check with a protractor. I want to measure the angle from A to B double prime to F prime. And that angle is apparently 68 degrees, I think is what I'm reading there. So that suggests that if I were to rotate, I want to rotate that angle upwards like I'm going around a clock. So it's a clockwise rotation, 68 degrees, I would get there. Now in GeoGebra, we can rotate in either direction and specify it. But remember, if I say a rotation of a certain number of degrees, that is not 180, positive measures mean rotate counterclockwise and negative measures mean clockwise. So I am going to do a rotation. I'm going to rotate the orange figure around the point that I need to stay fixed. And we're going to go negative 68 degrees counterclockwise. So that's the same as positive 68 degrees clockwise. And lo and behold, yeah, there was a little bit of precision error there, but that moved the two on top of each other. So I can see that whatever the angle measure size is between the segment of the point I want to land on and the segment of the point I'm currently at, that angle measure tells me how far to rotate. So to recap, to determine the congruence of ABCD to E prime, F prime, G prime, H prime, first I translated along a vector that moved the corresponding points B and E prime on top of one another. Next, I obtained the shape A prime, B prime, C prime, D prime in green, and then I determined I needed to reflect it. I reflected it over the segment on the one side just to get things facing the right way, and then I rotated around until the two segments landed on one another. The specific language for that shows up here on the screen. Look at it for a moment. Notice translations must have a vector, reflections must have a segment or line, and the rotation should give me an angle measure as well as a center. Notice I mentioned that the angle D that I'm talking about, it was about 68 degrees. I'm going to say it's a negative D degree rotation because the size of the angle formed between the two of those and the direction I need to move had to be clockwise. The final statement I would make in this problem is that since I determined a sequence of rigid motions mapping A, B, C, D onto E prime, F prime, G prime, H prime, that sequence of rigid motions represents the congruence between these two figures. Therefore, they are congruent.